Hello and welcome back to our class. In this video, we will discuss how to convert percent to decimals and to fractions and vice versa. We will also discuss the family tree of decimals for us to convert percent, decimals to fractions and vice versa easily. In addition, we will tackle also some word problems involving converting percent to decimals and fractions and vice versa. So if you are new in my channel, hit the subscribe button, like and share too. So let's now talk about the family tree of a decimal. So let's start with the terminating decimal. So the terminating decimal is actually a decimal whose final difference is equal to 0. Say for instance, we would like to convert a decimal okay, of 0.35 divided by 0.7. So again, what we're going to do is we will, write 0.035 divided by 0.7. Our objective is to make our divisor 0.7 as a whole number. To make this, we will move the decimal point one space to the right. Since we move one space to the right for our divisor, we will move our also one decimal point to our dividend. Now, our new dividend is equal to 0.35 divided by 7. So, let's divide now. So, zero point 0.3 or 3 divided by 7 is actually 0. Then we had 35 divided by 7 is equal to 5. But take note that 5 times 7 is equal to 35. And we will subtract. So this is equal now to 0. So this is the final difference. Let's have another example. 1.08 divided by 3.6 is equal to zero point 0.3. So let's move on to the another type of decimal, which is actually non-terminating decimal. So this is a decimal, that continues endlessly. However, this non-terminating decimal can be subdivided into two parts. So we have actually repeating decimal, and the other one is non-repeating, non-terminating decimal. So let's move on to pure repeating non-terminating decimal. So whenever we have pure repeating non-terminating decimal, it means that the entire quotient repeats infinitely. Say for instance, I have 7 over 11 is equal to 0.636363 infinitely, or I can rewrite 7 over 11 as 0.63 vinculum at or bar at the digits 6 and 3. Okay? Another example is 26 over 99, which is the same as 0.262626 infinitely, or I can rewrite 26 over 99 as 0.26 bar. So let's move on to mixed repeating, non-terminating decimal. So the definition is actually part of the quotient repeats infinitely. Example, we have 8 over 15, which is equal to 0.533 infinitely, or I can rewrite this one as 0.53, and I'll put bar on top of 3. Okay? Another example is 17 over 90. So this is equal to 0.1818 infinitely, or I can rewrite this one as 0.18. I'll put all the vinculum or bar at the top of 8. So let's discuss the non-terminating, non-repeating decimal. So it is a decimal with no group of digits repeating endlessly. So we can classify here the irrational numbers or imperfect roots. Say for instance, square root of 2 is equal to 1.412 and so on and so forth. Another example is example of pi that is equal to approximately 3.1415 and so on and so forth. Now that you have idea about the family tree of decimal, let's move on to converting percent to fractions. Let's recall percent in the word per, okay, means every, and cent is 100. So if we will put them together, percent means over 100 or for every 100. Say for instance, I had 40%. So if I have one whole and divide it into 100 equal parts, and I'll cover 40% or 40 out of 100. So there we have it. So we have 40 over 100 is the equivalent fraction of 40%. But take note that 40 and 100 is divisible by 20. So we have here 40% is the same as 2 over 5. Okay, so let's have some more example. Say for instance, I have 62.5%. So I can rewrite this one as 62.5 all over 100. But I'll make the numerator and denominator as a whole number by multiplying both the numerator and denominator by 10. So I have 625 over 1000 and divide numerator and denominator by 125. So therefore, 62.5% is the same as 5 over 8. Another example is 238%. So this can be rewritten as 238 over 100 and reduce if possible, which is actually divisible by 2, both numerator and denominator. So I have here 119 over 50 or 2 and 19 over 50. To summarize converting percent to fractions, so we have step number 1, write down the percent divided by 100. Second, if the percent is not a whole number, multiply both numerator and denominator by the power of 10. And finally, reduce the fraction if needed. So let's move on to converting percent to decimal. So this is our simply recall of the word percent. So per meaning to say for every, where cent is 100. So percent is for every 100. So 40% meaning to say that is 40 out of 100. Again, so if we will illustrate this one as a whole number, then divide this into 100 parts and cover 40 out of 100. So therefore, this is actually 40 hundredths. Okay, so let's have converting percent to decimal. So we have the following steps. First, we divide the given number by 100 or move the decimal point 2 places to the left and remove the percent symbol. So let's have example. So convert 12.5% to decimals. So we have 12.5. So what we're going to do is we will move the decimal point 2 spaces to the left. So we have 1 and 2. Then we have the percent symbol. Do not forget to remove the percent symbol. So what we have now is actually 0.125. Another example. So we will convert 227% to decimal. So we have 227. So take note that the percent is right after 7. Okay? So we will move the decimal point 2 spaces to the left. So we have 1 and 2. Okay? So the answer is 2.27. Do not forget to remove the percent symbol. Let's move on now to converting decimals to percent. So again, multiply the given number by 100 or move the decimal point 2 places to the right and annex the percent symbol. So let's have example. So convert 0.23 to percent. So we have 0.23. This time, we will move the decimal point 2 spaces to the right. So let's have 1 and 2. And do not forget to remove the decimal point here and transfer the decimal point here. So we have 23%. Do not forget to write or annex the percent symbol. Let's have another example. So convert 0.164 to percent. So again, so we have 0.164 and we will move the decimal point 2 spaces to the Right, so we have 1 and 2. So the final answer is 16.4%. Let's move on to converting decimals to fractions. So we have the following steps. So we have the given numbers becomes the numerator. The denominator is the power of 10 with zeros as many as the decimal places in the given number. Reduce the resulting fractions to lowest terms. So let's have example convert 0.46 to fractions. Take note that 0.46 can be rewritten in fraction as 46 over 100 because this is actually 0.46 or 46 hundredths. Then reduce to lowest terms, divide numerator and denominator by 2, so it will result to 23 over 50. So therefore, 0.46 is equal to 23 over 50. Another example, convert 0.85 to fraction. So take note that 0.85 is actually 85 hundredths or 85 over 100. And divide both numerator and denominator by 5, so we come up with 17 over 20. So 0.85 is the same as 17 over 20. Let's move on to converting pure repeating decimals to fractions. So the given number becomes the numerator. The denominator is a series of nines as many as the decimal places in the given number. Reduce the resulting fraction to lowest terms if needed. So let's have example number 9. Convert 0.84 to fractions. So take note that 0.84, so we have 84 over 99 because we have two decimal places. There are two repeating digits, namely 8 and 4. Then reduce 84 over 99. So divide both the numerator and denominator by 3. So we come up with 0.84 bar is the same as 28 over 33. So let's have another example. Convert 0.05 bar to fraction. So notice that we have three repeating digits. We have 4, 0, and 5. So we come up with 405 over 999. Then divide both numerator and denominator by 27. So we come up with 15 over 37. Let's move on to converting mixed repeating decimals to fractions. So the number is the difference between the given decimal and non-repeating digits. The denominator is the series of nines and zeros, 9 for repeating digits and 0 for non-repeating digits. Reduce the fraction if needed. So say for instance, we have this decimal. We'd like to convert this decimal to fraction. So take note that the given is 684 as the number minus 6, which is non-repeating digit, divided by the denominator will be series of nines and zeros. Since we have two repeating digits, 8 and 4, so we will write two nines and one non-repeating digit, which is 6, so we have 1 0. Simplifying it further, so we have 678 all over 990. Then, divide it by 6, both the numerator and denominator. So, the given decimal is the same as 113 all over 165. Another example, so we like to convert this decimal to fraction. So take note that we have 1036 as our number minus the non-repeating digits 1 and 0, so we have minus 10, all over. Since we have two repeating digits 3 and 6, so we will write two nines, followed by two non-repeating digits 1, 0, so we have two zeros here. So simplifying it further, so we have 1026 all over 9900. So the given digit, if we will divide both the numerator and denominator by 18, so the given decimal is the same as 57 all over 550 as fraction. Let's move on to converting fractions to decimals. So divide the numerator by the denominator. or multiply both terms by a power or a factor to obtain a power of 10 as denominator and simplify. So let's have example, change 3/5 to decimals. So divide 3 by 5. But I cannot get 5s in 3, so I'll write here 0. Then decimal point, and I put another 0 here. So 30 now divided by 5 is equal to 6. Do not forget the decimal point. So therefore, 6 times 5 is equal to 30. Subtract, so 0. So 3 over 5 now is the same as 0.6 or 6 tenths. Another way to convert 3 over 5 is I'll think of a number that I'll multiply to 5 to make it 10. And that number is equal to 2. So take note, 5 times 2 is the same as 10. And I'll multiply the same number to 3. So, meaning to say, 3 times 2 is the same as 6. But take note that 6 over 10, meaning to say, I have the decimal point. I'll simply move one space to the left. So this is the same as 0.6. Let's have another example. Change 14 over 4 to decimals. So now what we're going to do is write 14 over 4 and think of a number that you will multiply to 4 to make it 100. Okay? And that number is actually 25. So 4 times 25 is equal to 100. And then 14 times the same number, 25, 14 times 25 is equal to 350. Okay, so I have now 350 over 100. So I have here the decimal point, 350, decimal point here. I'll simply move two spaces to the left. So I have 1, 2. So now 14 over 4 is the same as 3.5 or 3.50. Okay, so let's move on now to converting fraction to percent. So multiply the numerator and denominator by a factor to get a denominator of 100. Annex the percentage symbol. Say for instance, you would like to change 18 over 60 to percent. So what I'm going to do first is reduce 18 over 60 to lowest term. So both numerator and denominator is divisible by 3. So I have now 6 over 20. And take note, 20 is a factor of 100. So 6 over 20. What I'm going to do is think of a number that I'll multiply to 20 to make it 100. So that number is actually 5. So 20 times 5 is 100. I'll multiply the same number to numerator. We need to say 6 times 5 is equal to 30. Take note that 30 over 100, meaning to say this is 30 over 100 or 30%. So take note that 18 over 60 is the same as 30%. So let's have another example. Change 84 over 24 to percent. So again, what I'm going to do is reduce first 84 over 24 to lowest term. And both numerator and denominator is divisible by 6. So I have now 84 divided by 6 is equal to 14 over 4. But take note that 4 is actually a factor of 100. So 14 over 4. Think of a number that that if you will multiply to 4, it will become 100. And that number is actually 5, or 25 rather. So 4 times 25 is equal to 100. 14 times 25 is equal to 350. So take note that 84 over 24 is the same as 350%. Let's analyze this word problem. Linda made 200 tarts. She sold 60% of them in the morning and 25 hundredths of the remainder in the afternoon, and gave away to his relative all the rest. How many tarts did she give away? So let's try to diagram the given situation. So the entire part is 200. Okay? However, 60% or 6 out of 10 sold in the morning. So meaning to say we have 4 out of 10 are actually remainder. However, 0.25 or 25% of the remainder are sold in the afternoon. So meaning to say 7 parts out of 10 were sold in all. And 3 parts were given or given away. So meaning to say 30%. So if we will solve this, we have 10 units is equal to 200. And take note that 1 unit is equal to 20, meaning to say 200 divided by 10 is equal to 20. But I have 3 parts, okay, were considered as given away. So meaning to say 3 units is equal to 60. So therefore, she gave away 60 tarts. Let's consider another example. Alex spent one-third of his pocket money on a toy airplane and 25% of the remainder on a toy robot. He had 600 pesos left. How much did he spend altogether? So let's try to diagram the word problem. So we do not know how much money he has at first. But according to the problem, one-third of his pocket money was spent on toy airplane at first. So we will divide the entire whole into 3 parts. So one-third is dedicated for the airplane. And we have 2 out of 3 parts are remainder. Next, from that remainder, we divide this one into 4 equal parts. Why? Because take note that 25% is the same as 1/4. Let's recall. So 25% is actually 25 over 100, or the same as 1 out of 4. It means that we will divide the entire remaining parts into 4 equal parts. So meaning to say, okay, we will divide the other remaining parts into 2 also. And take note that out of that 4 remaining parts, 1/4 was spent for robot, or 25% of the remainder, okay, are dedicated for toy robot. Next, so there are 600 pesos left. So by analyzing the illustration, we can say that 3 units is equal to 600 pesos. 1 unit is equal to 600 divided by 3, or 1 unit is equal to 200 pesos. Since from the illustration we can see that there are 3 units are dedicated for the spend altogether, so we have 3 units is equal to 600. So therefore, we spend 600 pesos altogether.